My name is Khazir Khan. You are watching Learn to Grow, and today we are with the topic Supernode. We are having a circuit right here, and you can see that there here is a circuit which has both current and voltage sources. These two are current sources, and this is a voltage source. So this cannot be simply solved by nodal or mesh analysis. Uh, Here a special case is applied. Here you can see that there is a voltage source which is in between two non-reference points. Now let me explain what is non-reference points. Non-reference points are basically non-ground points. This is a ground node, and these are non-reference or non-ground nodes. Okay, so if a voltage source is in between two non-reference nodes or points, this the whole node becomes a this whole node becomes a supernode. Okay, so as you can see with the name that supernode is used to solve this particular case. Okay, so what is basically supernode is basically a special case of nodal analysis, and it is used to solve supernode problems. Now in supernode there are two parts. First part belongs to your KCL, and the second part belongs to KVL. Okay, in the first part we make this supernode a short circuit. Okay, so in the first part we are going to remove it. This whole will become a short circuit. Okay, now we are proceeding with our first part. The first part is this, and then when we apply KCL we define currents first. So here you can see that this I1, you can say this I1 as 2 ampere, or simply as 2 ampere is flowing in this direction. Okay, and here this is I2 also, because the wire is same, I2. Okay, and here this will be I3. You can assign any of the current, you can assign any number with any direction, because you are firstly assuming. Okay, then 7 ampere. Okay, now you have assigned the currents. Now apply KCL on node 1 and 2. Now let's first name the nodes. What are the nodes? And this is node 1 and this is node 2. Okay, node 1 and node 2 having voltage V1 and V2. Simple. Okay, because the node have same voltage. A node have same voltage, but nodes are different, so they have different voltages, and due to the potential difference current flows. Okay, so on supernode, applying KCL on supernode, applying KCL on supernode, Kirchhoff's current law on supernode, or this short circuit and between 1 and 2, you can say. Okay, so here how many currents are entering and how many currents are outgoing. Here 2 amperes entering, 2, and which one is entering? Only 2 was entering, and I2 was going outward, and I3 also was going outward, I4 was also going out, 7 was also. Okay, no, I2 was in. No, 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 no. Here you can clearly see that because of this short circuit, this resistor become useless. Why? What is the reason? Because you can see there when we are applying KCL, we are seeing that during during the distribution of current, I2 was also entering and I2 was also exiting. It is just like that we are uh, joining the ends. Here the two 10 ampere and we have joined. Here I2 is flowing and I2 are also coming. So there is no need of this resistor to solve. Okay. So we can simply put this also. Okay. I2 was also entering and I2 was also exiting. Here I2 was also entering and I2 was also exiting. So we can put it like this also. Okay. Or we can simply remove, or we can simply remove this resistor too. Okay. Now we have put it our current. Now we can are assigning I2. We are assigning our currents. Okay. What was I2? I2 will become, first we can cancel them out. We have cancelled. Okay. Simply just solving it. No complications. This is quite simple, quite easy to solve. Okay. So what is I3? I3 is V1 upon 2. Okay. V1 upon 2 according to your uh, Ohm's law, because I is equals to V over R. Okay. And then I4, what will be I4? I4 is this V2 over 4. Okay. V2 over 4 plus 7. Now our equation will be in term of V1 and V2. This will become, here you can see that we have got our first equation in terms of voltages V1 and V2. Okay. We have two variables to know. So we require two equations to solve them. So from where our second equation will come? Our second equation will come from the second part of KVL, Kirchhoff's voltage law. How the Kirchhoff voltage law will apply here? We will simply, we first assume the voltage source, current sources. We have considered the current sources and we ignored the voltage source, supernode. But in the second part, we will ignore the current source and we will consider the vo- voltage source. We are ignoring now current sources and we will consider the voltage source. Okay. So here we will again put our node back. What was this? 2 volt plus sign. Okay. And ignoring this will become, when we ignore a current source, we open them, and when we ignore a voltage source, we short them. Always remember. Okay. So now my equation will can come from this looping. In KVL we do looping. Okay. Say that I1 current is flowing in this direction. Say that I1 current is flowing in this direction. Okay. Only I1. That was of which I am removing right now was the part of your Kirchhoff's current law, but we are now dealing with the Kirchhoff's voltage law. We are assigning a new current. says that I1 current is flowing in this direction. So what will the voltage is? What Kirchhoff voltage law basically says is that sum of all the current all the voltages that are in a loop has a sum of zero. Okay, so we can say that applying KVL. In this KVL part, we will now consider the voltages. 2I1 voltages, plus sign, negative, plus negative. In in Kirchhoff voltage law, we consider the voltages. In this 2 ohm resistor, V1 is flowing. Okay, 2 ohm resistor contains V1 voltage and 4 ohm resistor contains V2 voltage, but we will go with the direction. According to the direction, minus sign is striking first, so minus V1. Okay, then our voltage source minus V2 minus 2. Okay, minus 2 plus V2. Oh, this is according to this because minus sign is striking first with V1. Okay, according to the direction, and then minus 2 and plus V2. Follow me. Now we will solve this V1 minus V2 plus 2. We now have our second equation in terms of voltages. We now have both the equation in terms of voltages. We can simultaneously solve them. I am taking V1 from this equation. It will become this is V1. V1. Now it will become V2 minus 2. Okay. Putting it in 1. Okay. This was 2. I have made this in this form and I am now putting it in 1. So in place of V1 I'll put this 2 2 V2 minus 2 and plus V2 plus 20 equals to 0. Okay, now I'm solving this. Now you can see here I have successfully solved V2 value, and through this equation I have got the V2 value. Now I'll put V2 in any of the equation to get my V1. I'll put in simply in this equation. Okay, so in place of V2, V2 minus 2. Okay, so it will become V2 minus 2. Okay, minus 7.3 volts. I have got both the values successfully. Okay, so what basically Supernode case says that we can analyze the voltages of a circuit which have both current and voltage sources. You cannot simply analyze it by nodal analysis or mesh analysis. Supernode case or super mesh case is applied. We will discuss super mesh in my next video. And if you have any question, any query regarding this procedure, you can ask me in comment box. Don't forget to subscribe Learn to Grow by clicking on the button right there. I will see you in the next tutorial. Till then, goodbye.